Good evening, this is Mrs. Ellsworth. What we're going to be talking about is classification of matter. And when we go and classify matter, which we do all the time, even with home, we go and we classify, like if we clean out the dishwasher, we are separating things and by their classification, and we are able to categorize them. Anyway, when we classify matter, we are going to look at specific characteristics that will help us bunch up or group up different types of matter so that we can categorize them. And so, like, for example, the next time we meet, we're going to be given these 5 different objects here: a rubber band, copper wire, a paper clip, graphite in your pencils, and also toothpick. And we will classify them according to different characteristics or properties that they have. And we do, like I said, we do this all the time. For example, we could be classifying our laundry at home so that we can do our laundry more efficiently, and so we don't ruin things, because, if you put your darks with your whites, you could ruin them. Anyway, so for us to classify matter, we have to figure out, well, can this be separated by physical means? Like when we did our train wreck experiment, we separated with magnetism. We separated by dissolving one substance and filtering out the other. And then we even evaporated. So those are all physical means. Physical means could also mean that you're picking it out by hand. So that would have been difficult with the train wreck, because we would have had to, those were, like a million different little particles that we would have had to separate. So that wouldn't be very, it wouldn't be very easy for us to do it that way. So we did it by other methods, physical means. Now, if it cannot be separated by physical means, then that means that it is a pure substance. And pure substance are elements, and they are also compounds. Okay? And if it can be separated by physical means, like what we did with evaporating the water, it was a mixture before that. It was salt water. So we have to look at it and ask, does it look all the same throughout? If it is, then it is a homogeneous mixture. Okay, if it does not look all the same or uniform, if it looks very different all throughout, and once we looked at that whole mixture of our train wreck example, then we were looking at a heterogeneous mixture. Okay, now just to help you out here, hetero means different, looks different, and homo means same, so it looks the same all throughout the mixture. Like the salt water looked like water. It looked all the same throughout. But then when it was all mixed together with all 3 substances, it was definitely looked different once you started looking inside of it a little bit more. But let's go and look at the pure substances portion of it and examine each one of these. The first one that we'll talk about is going to be the element. Now, elements are pure substances again. That's what was above it in that little diagram that we just had. And an element means that all the atoms are identical. So, for example, if we had this copper vase here, then every single atom in this would be copper. Well, except for where it's turning on the outside, where it's oxidizing. But that's an example of a pure substance. Also, other elements like the graphite in your pencil lead, that right there is graphite, is all carbon. And there are other types of pure elements that we see. For example, the silicon chips inside of your computers are made out of silicon, and that's just one type of atom. Okay, the other pure substance is a compound. Now, compounds, they're where we have a couple of atoms that are fixed together, okay, and they're in a fixed ratio. For example, water is H2O. There is 2 H's to 1 O. It will always be that exact ratio, or it is a different compound. If it was H2O2, then it would become hydrogen peroxide. I shouldn't say become. It is hydrogen peroxide. And so that ratio is a 2 to 2 ratio, where water is a 2 to 1 ratio. And so they're different compounds. Now, it's different when I go and look at salt. For example, sodium alone and chlorine alone is very different from the crystal that we have right here. Sodium can't even be in water. It explodes from it, and chlorine is a gas that is harmful to us, but yet we can eat this because when it's a compound, it's got very different properties or characteristics. Okay, and so stop the video here. Now what I'd like you to do is I'd like you to look at these different representations or these models and ask yourselves, is this a compound or is this an element? Okay, this contains all one type of atom, so that is going to be an element. This one is water. For most standards, so that we have hydrogen is white and oxygen is red. And so this would be water, so they're all the same exact molecule. So that's going to be a compound. Here we've got elements that are stuck together. That might make you think there's a compound, but if you'll notice they're the same exact color, so they represent O2, oxygen, and so this would be an element also. This one's got more than one type of element, and so it is just a compound. These are all pure because they've got all the same thing in each example. Now let's look at the other side of our graphic representation here. Let's look at the mixture side. Okay, does it look all the same throughout? Well, then that would be a homogeneous mixture. Homogeneous mixture is another term for a solution. Like when we had our salt water solution that we went and separated in our train wreck. If I look at my soda pop, that's also another solution. When we go and look at it, they look all the same throughout. Like syrup is also another one too. And those type of things are evenly distributed. For example, when I go and I mix up my Crystal Light lemonade and I stir it up and I put it in the fridge and come back to it, and every cupful from it tastes like lemonade. It doesn't separate or anything. It doesn't become more concentrated at the bottom of the pitcher or anything like that. It stays evenly distributed all throughout the whole container. There are also very, very small particles. In fact, these particles never settle out. They always stay all within. And here's a good example of it. Ice solution, of saline solution, and that's a good example of a solution. Okay, let's look at another type of mixture, heterogeneous mixture, that looks different all throughout. So like my salad that I ate for lunch today looks all different throughout, so that would be heterogeneous mixture. So heterogeneous mixtures, they look different throughout. They are not uniform. And that's quite often the term that you see in so many definitions of a heterogeneous mixture. And that means that it has an uneven distribution. Some things can settle out because they have bigger particles. There are two types of mixtures, and this is important. And there are two types of mixtures, and we'll talk about this again later on. One is called a colloid, and another one is a suspension. But here's an example of a mixture, granite rock. Okay, it doesn't even look all the same throughout. That's why we like it on our countertops, because we like that texturized look to it. Okay, so let's quiz ourselves again here. Go ahead and stop it and ask yourself, does this look like a mixture, a compound, an element? What type of mixture would it look like? So go ahead and stop. Okay, looking at this one, you know this one's a pure element. Okay, and this one looks like that they're all the same thing, so that means it would be a compound. This one has got different, well, those two are the same, but it looks different from this one. This one looks different from it, so this would be a mixture. And now it kind of looks like things are evenly distributed all throughout, so I'm guessing it's going to be a homogeneous mixture because I don't see anything really settling out on this one. Anyway, back to heterogeneous mixture. A colloid is one type of one, and those have medium-sized particles. That means that they can stay suspended, and but they're bigger particles. In fact, they actually kind of stop light. And the Tyndall effect test is one that we do to see if it is a colloid. And for example, if I was going to go and shine a light into Jell-O, then it would scatter the light and kind of make that bowl of Jell-O glow. Okay, these particles don't settle out because they're still really small, but they are larger than the solution size so that they scatter light. An example would be the homogenized milk. Okay, the homogenized milk actually has got fat that has been about 4% of the fat molecules are still in the solution of milk. Anything more than that will settle out. And so then they make it so it all stays together because people like that taste, and so then they appreciate the content in it. And of course there is also milk that's got less fat content in it too. But if I would shine a light in this, it would glow pretty, it would glow, the light would not shine straight through it, so it would have a positive Tyndall effect test. A suspension is the second type of heterogeneous mixture, and that has really large particles. In fact, they are so large that they will scatter light or even block light, but they will settle. So like if I had, I have an example at class that we'll see of a dressing that you have to shake to be able to have it evenly distributed. And so that type of salad dressing or any type of medicine that you have to shake, anything you have to shake, fingernail polish you have to shake, anything like that is because the particles will settle out because they're so large because it's a suspension. Okay, fresh squeezed lemonade is a good example because there are things that settle out on the bottom, so you want to stir it before you drink it. And here's that type of dressing that I'll show you in class, how it separates. And then you even get bigger particles on the bottom. Okay, so now we need to add two more things to our graphic diagram. A solution, a colloid, and a suspension. Okay, smaller particles, medium particles, bigger particles. Okay, so it kind of like goes from smaller to larger as you go left to right with this graphic representation. Oh, here's a joke. Getting emulsified. These are different types of colloids here, so that if it's emulsified like some of the ones that you can buy, then you don't have to shake them. Tomorrow we'll be doing a chemical sunset demonstration in class to show the different types of matter that we were just talking about. And that's all for right now. I'll have another video on physical and chemical properties and physical and chemical changes.